Okay, so I'm going to be going over some of the problems from the homework quiz, starting with number 1. So problem 1 asks you to solve some initial value problems. So the first one is x prime of t equals e to the 2t plus 3t minus 1, and we're told that x of 1 is equal to 0. So recall what you're trying to do when you have a differential equation. You have an unknown function, x of t, which we're trying to find. And in this case, we're told that the derivative of that function has to be equal to this function of t. So since x, the unknown, only appears on the left-hand side, and the right-hand side only depends on the variable t, we can find x just by taking the antiderivative of both sides. So take the antiderivative, and what do we get? We have that x of t equals the antiderivative e to the 2t plus 3t minus 1 dt. This is equal to 1/2 e to the 2t. So remember, the antiderivative of e to the t would just be e to the t. We need to put a 1/2 out front because by the chain rule, when you differentiate this function, the 2 in the exponent would come down and cancel that out. Then the other two terms, we use the anti-power rule, so we'll get 3/2 t squared minus t, and then of course we have an arbitrary constant at the end. And this arbitrary constant is determined by our initial condition. So x of 1 equals 0 tells us that if we plug in 1 here, we should get 0. So 0 is equal to 1/2 e to the 2 times 1, so e squared, plus 3/2 from this term, minus 1 plus c. And that tells us that c is equal to, let's see, negative 1/2 e squared minus 1/2. So this means that x of t must be equal to 1/2 e to the 2t plus 3/2 t squared minus t, then minus 1/2 e squared minus 1. So that's the answer to part A. Part B gives us the equation x prime equals pi times x with x of 1 equal to 2. Now many people tried to solve this by taking the antiderivative of both sides, but that doesn't work because here x is an unknown function of t, and x appears on both sides of the equation. So since we don't know what x is, it's what we're trying to find, we can't take its antiderivative. Unlike here where we had a concrete function of t that we knew how to take the antiderivative of. So that means we have to do something else for an equation where the unknown function appears on both sides of the equation. And if the equation looks like x prime equals some constant times x, we've been told, or we saw it earlier just by guessing and checking, that the general solution is that x of t equals a constant times e to the pi t. And then we use the fact that x of 1 is equal to 2 to see that 2 is equal to e to the pi times 1, or just pi, times c. And that means c is equal to 2e to the negative pi. So if we use that fact and plug back into our general solution, we get that x of t is equal to 2 e to the negative pi e to the pi t, which we can combine to e to the pi times t minus 1. So this is the solution to that differential equation.